particular video, we will discuss the problem hand of straights. The problem says that Alice has some number of cards and she wants to arrange the cards into groups so that each group is of group size and consists of consecutive cards. Now you are given with the array called hand. You have to actually arrange these numbers, these array, into some group size with consecutive cards. Okay, let me give you an example. For example, this is the test case. This is actually a very good test case. So if you will take this test case, let's see how it will work. So if this is the array given to you, then what will happen? What will actually happen is that we will, for each number, we will get its group. Okay, that whether it is possible or not. For example, if you will see, one group will be 1, 2 and 3. Simple. This is a group because you can see that group size given to you is 3. Okay, group size was given to you as 3. So you have to make groups of size 3. So you can see that this 1, 2, 3 is a group. It is created. Then we can see that 2, 3, 4 can be done. Okay, and then this 6, 7 and 8 can be done. So guys, this is how we can actually create these 3 groups of size 3, right? But in this case, if you will see this second case, when we have this as the number as 1, 2, 3, 4, 5, this is an array, and our group size was also 4. It is not possible because when the array size is 5, you cannot create groups of size 4. So the very first thing is that the size of the array, the size of this hand array, this is hand array, this should be divisible by the group size. Then only we can divide the array into groups of that particular size. That's a very basic thing. But if it is not divisible, for example, if the array size is 100, group size is 7, how we can divide this 100 into 7 groups, like into groups of size 7? It's not possible, right? Because it is not divisible. So हम कैसे divide करेंगे, right? So the very first thing is it should be divisible. So I'm removing this case. I hope that you got it. इस case में it should be divisible, right? So the very first thing, if you will see, what I will write in the code is, okay, let's write the code at the last. Okay, so now how we can solve it, guys? The thing is that this problem can be solved in brute force approach only. The brute force approach means in order of n into, or we can say n square also, basically n into group size time complexity. Yes. So this is the like you know the most optimized possible way. By the way, there is one more way of solving this problem, which is actually using priority queue. Okay, and using priority queue in Java, it can be done in order of n log n time, but in C++ it will be again order of n square, like n into group n. I will tell you why. I will discuss both the approaches. First, I will discuss the approach without priority queue, where priority queue is not used. Okay, then I will discuss the approach with priority queue, and I have the code for both, so don't worry. Okay, we will discuss that. Let's discuss the first approach, which is without priority queue, and it's a very brute force kind of approach, we can say. See guys, in that approach, first of all, we will sort this array hand. We will sort this array. Okay, let's sort this array. So it will become 1, then 2, then 1 more 2, then 3, 3, 4, 6, 7, 8. So this is how the array will look like after sorting. Just wanted to confirm whether, yeah, it has also has 9 elements, right? This is the hand array. Okay, now if you will see, this is the first element. Now guys, for every element, what you will do is, you will check, okay, this is the first element. Now you will check group size consecutive elements for this particular first element. This will be your approach for the problem. तो हमें कितने चाहिए? We want to make group of size 3. So we got 1. Now we'll get 3 consecutive elements including 1. So 1 is there. Okay, we got 1. Then 2 is there. Then 3 is there. So we got 3 consecutive elements, 1, 2, 3. Means this can be a group. Okay. Then I will move forward. Now I came here. This is already taken. So maybe we can cut it. We can make it 0 or -1. Anything we can do, right? Now I will come here. Now for this 2 also, again I have to take 3 consecutive elements. So 2 is gone, 3 is gone, 4 is gone. Now this is also done, this is also done, this is also done. Now came 6. So for 6 again, I will take 6, 7 and 8. And finally, when the whole array is taken, means the group is possible. And this will be our approach for solving this particular problem. This will be our approach, right? So what I will do, if you will see the code, what I'm doing is, uh, that I will say, first of all, I will find the length of the hand. Okay. And as I said, the length should be divisible by this group size. Then only it is possible, right? And if it is not divisible, I will that time return, at the same time this return false. Means it's not possible, right? Next, what I will do, I will sort the hand array, hand vector. Okay. I will sort hand like this. Now after sorting, what I will do, as I told you, after sorting, we have this. Okay. So I will iterate through all the sorry. I will iterate through this array one by one. So 1, 2, 2, 3, 3, 4 and so on. I will iterate, okay. So what I will do, I will write a loop starting from 0 going up to n I plus plus. Okay. Okay. Now what I will do, now for every element I have to check. For example, this element is 1. So if this is 1, I have to check there should be 3 consecutive elements for this one. For example, 1, then 2, then 3. If it is present or not. If it is not present, means answer is not possible. If it is present, means it's fine, right? For example, let's say if there is no 3 present, or let's say there is, instead of this 4, there is a 5, for example. Then what will happen? See, for 1 it will find, okay, it will say 1 is present, 2 is present, 3 is present. Got it? Now for this, it is already cut. So now this it will find 2 is present, 3 is present, but 4 is not present. It should be a 4 because it should be consecutive. So when it will say, okay, 4 is not present, means starting from 2, we are not having a group, means answer is not possible. That's the basic simple thing, right? So what I will do now, I will check the same thing. So let's assume there is a 4 only, okay? So up for every element, I have to check that its forward elements are present. Okay, so I can write the logic here also, but it will be better if we can write a function for it. So what I will do, I will write a function called check, which will actually check that starting from index I, that particular ith element should be present, like that ith element up to I plus k, all the consecutive elements should be present. I plus group size basically, right? So if you will see here, what I'm doing is I will take the input of these two things and obviously input of I means the current index where we are. Okay, the current index where we are. If you will see what I will do next, what we will do next, देखो, first of all, what I will do, if we are, let's say, currently at this element 1, index 0, element 1. So if we are at element 1, now we have to search for element 2 and element 3 also, right? That it should also be present because we want a group size of 3. Okay, and once they all are done, we will make them -1, -1 and -1. This is what we will do. Why -1? Previously we were cutting now we will make it -1 so that we should know okay, this element is being taken. So what I will do, I will make this hand of I as -1. Means okay, we have taken this element. This we have considered as a group. तो ये -1 हो जाएगा. अच्छा, और -1 होने से पहले what I will do, I will also take one more element, let's say x, where actually I will store hand of I. So that हमें पता होगा यहाँ पे क्या था. अब देखो हमें पता है कि x कितना है, x is 1. Okay, x is 1. Now I have to find elements which is, so currently x is 1. Now I have to find elements 2 and 3 also because group size is 3. So I want 2 more elements which are consecutive to this x. So for that, what I will do, I will take 2 things. Okay, I will first of all take a count. Okay, count. And count initially is 1 because we got one element of the group which is x. Now I have to find consecutive elements of x until this count is less than group size. So I will say while count is less than group size, and I will do one more thing, guys. I will increase the value of I, and I will say that I should be less than n. If this thing is there, okay, fine. Ab dekho guys, we are currently at x. Next element we want is x plus 1. So now if our element hand of I is equal to x plus 1, if it is equal to x plus 1, means we got a consecutive element. When we got a consecutive element, I will increase my count and I will increase my x also. For example, we were searching for x plus 1, which is 2. So when I will come here, you will see that when I will come here, you will see that x plus 1 is now found. So when x plus 1 is found, what I will do, I will first of all increase my count. Now my count also became 2. 2 means I got 2 consecutive elements. Count became 2. Also my I will also became 2 because we got 2. So next I will search for 3. So x plus 1 is not 3. Okay, and one more thing, because we got this element, I will make this also as minus 1. So I will make my hand I uh, also as minus 1. Okay, cool. And then I will move forward. So I will always be increased. अब जैसे कि ये था, अब और आगे बढ़े हम लोग. Now my I came here. Now you can see this I is not equal to x plus 1. So it should be x plus 1. It should be 1 more than x. X तो मिल गया है, उसके आगे गए हमें चाहिए. So this I is not x plus 1. So I will simply move forward here. Now this is actually x plus 1. So again what I will do, I will increase my count, I will increase my x, and I will make it minus 1. And now you can see that my count is equal to the group size. So finally I will say if my count is equal to group size, okay, if my count is equal to group size, means return true, else I will say return false, it is not possible, right? अब देखो फॉर एग्जांपल इसके लिए हो गया. अब दिस लूप विल स्टॉप, इट विल रिटर्न फॉल्स, इट विल रिटर्न ट्रू. तो मैं क्या करूंगा, तो बेसिकली इट विल रिटर्न ट्रू. ठीक है, अब वी विल चेक फॉर द नेक्स्ट इंडेक्स. सो नेक्स्ट इंडेक्स क्या है, currently we checked starting from here, currently we were checking from here, then we check this index. अब हम यहाँ से start करेंगे. अब see guys, this is already minus 1, so we will not consider it. Now we will start from here, means x is 2. So if x is 2, now you have to search for a 3. Next पे आए, ये तो 3, ये तो already minus 1 है, और next पे आए, this is a 3, means you got a 3 and count also became 2. Again move forward, now you are searching for 4. 4 is also present, yes, count became 3. Again ये सब minus 1 हो गया, and we again got a group of size 3. And then same for 6, 7, 8. अगर यहाँ पे 5 होता है, if there is 5, then obviously answer would not be possible. Your count will remain 2 only, and at the last it will return false, right? This is how guys it will actually work. Okay, and then finally we will use this particular thing here, and I will call this function if hand is not equal to minus 1. We will only call this function if hand value is not equal to minus 1 currently, because you can see for every element that I've taken, we are making it minus 1. So no need to check again for it. They are already taken in a group, right? So if a hand is not equal to minus 1, I will call this check with this hand group size and I. Okay. And guys, and if this check is false, means if for any of the element a pair or a group is not possible, simply return false. But if for all the indexes it is possible, at the last I will return true. Okay, so this is how we can solve the problem. Let's try to run it. Okay, n हमने नहीं लिया यहाँ पर. N is basically hand dot size. Yeah, you can see that our sample discussions are running. Let's submit this. Yeah, you can see we have got the right solution, right? If you will see here, what is happening, we actually have the time complexity. Look, first of all, there is no extra space taken. So space complexity is not there. There is no space complexity. If we talk about time complexity, see, this is n log n. Okay. This is order of n. And in this order of n, we are calling a function check. And guys, this check function is actually, running how much time? Count group time. Count group time. So in the worst case, you can see that your time complexity will be order of n log n plus n into group size in the worst case, right? बेस्ट केस में तो ये होगा ना कि देखो, बेस्ट केस में ये होगा कि दिस विल रन और ये क्या करेगा ना, ग्रुप साइजेस को -1 कर देगा, सो दैट पर्टिकुलर ग्रुप साइजेस विल नॉट, this function will not be run. So eventually this loop will then call this function n by check time, whatever group numbers are. Then in that case it is order of n. So best case it is order of n, but in worst case it is n into group size only. Okay, so this is how we can solve it using without priority queue. Up guys, there's a one more method of priority queue. Okay, priority queue. How we can you know solve it using without with priority queue. So guys, as I told you, with priority queue we can actually solve it using Java. Like with C++ also we can do, but in Java time complexity will be better. It will be n log n. Let's discuss what. So see, I have actually submitted that code before. Yeah. So if you will see here, this is the code of priority queue. Logic is here also same. Here what we did, here actually to sort the array, I am storing the array in a priority queue. Okay, so now the numbers are stored in a priority queue. Now I'm simply saying while the size of priority queue is greater, take the top element of priority queue, just like there also we're taking x, and then for all the consecutive numbers from x to x plus group size, remove them. For example, ये यदि मान लो, so what they are saying is, they are saying that first of all, store all of them in a priority queue, in a min heap. So it will be 1, 2, 2, 3, 3, 4, 6, 7, 8. Now take the top element, which is x. Now remove x and up to where? Up to group size. Means remove all the consecutive element of x up to group size. And if a element is not present, return false. For example, x1 है, तो 1, 2 and 3. Remove all of them. ठीक है, अब ये सब चलेगा. Now priority queue becomes this. Now again, now its top element is what? 2. तो अब क्या करो, 2, 3 and 4 is removed. Now its top element is 6. Now 6, 7, 8 is removed. So same thing we are doing, just like we are doing here. We were doing here. Same we are doing using priority queue also. If you talk about time complexity of this now, so see, to insert in priority queue also, it will take how much time? It will take actually n log n time. And guys, here also to remove, it will take n log n time. So ultimately I will say, in worst case, in the worst case, here also the time complexity is little bad. It is not that much easy. It will be complex, but yeah, it can be a possible solution. But I'm not claiming that time complex is very better here. Here also time complex will be very similar to the previous one, the previous solution, but yeah, it can be little better. And guys, why I'm saying that in C++ this will be little difficult. So C++ will be same होगा. In place of this priority queue, use C++ का priority queue and all of that. So अगर आप बोलो तो मैं लिख भी देता हूँ इसका कोड, तो कुछ नहीं है. अगर I will write this in C++ ना, how it can be done, how it can be done. तो सिंपल यहाँ पे ऐसे कोड लिखते हैं, this became size, and in C++ priority queue कैसे होता है, it is like this ना. So it's a min heap, okay, minimum elements should be at the top. So I'm creating a min heap in C++. ठीक है. अब लोग इसमें केस बस ये आ रहा है कि when we will use this C++ ना, this is how the code is written, we will push it, this all will be as it is, we will pop it, okay, but there is no as such remove function in C++. Remove, like to remove a specific element, there is no inbuilt function in C++, what I know. That is why in C++ it will be little like we can remove it still, but for remove you have to again iterate through the whole priority queue and then remove that specific element, which is again take a order of n time. Okay, so like it's not that much feasible in priority queue as I said, because in priority queue there is no remove function in C++, but yeah, in Java you can see that we did it, and this is how we can actually do. Okay, so guys, we discussed two basic approaches of this particular problem. The first approach is using without priority queue. Okay, second is using priority queue. Logic is same, just that see I'm not saying two approaches. I will say that the logic is same, but the implementation is different. Once we didn't use priority queue, in the next we use priority queue, right? So guys, this is how we are solving this particular problem. I hope that you have got the understanding of this particular problem. If you got it, please do like this particular video. Please do subscribe to the channel. Okay, and uh, keep watching these videos. Thank you.